Okay, sound check, test, test, test. I see the level meter going okay, and you can probably hear cars going outside. So if that's too noisy, I can try to shut the window, but I'd rather not because it's quite warm today. And are there any people in the stream? Is there stuff happening? Broadcast looks fine. So if there's anyone in the chat, please feel free to raise your finger, say something. Probably test this on my iPad as well to see if I can watch my own stuff. So yeah, I can see myself, so that's pretty good. And Matthias Danielson is here, I think. Now I have to find my studio again. I'm wondering how that's... here. Perfect. Okay. So it does work, it seems. Good evening. Drink of the day is kind of pina colada with a super tiny dash of rum from the Dominican Republic, I think they're called. Not a lot, just a dash for the taste. And today we have the Atari 7800. A machine that I've never had before. I do have two 2600s, one Vader model that's currently not used, and a 2600 Junior because it's smaller that I occasionally use and play. It looks very similar to this one here, but much slimmer, much smaller. This one is one bulky wedge. The interesting things about the 7800. Oh, there's another one in the stream. Menage Roy. Hi. Hello. The interesting thing about the 7800 is this is basically NES era, more or less, and Master System era. There was also 5200, yes, which was not very successful. I think the 7800 was a bit more successful, but I think was a third place behind Master System and NES. So I don't see these very often. The 2600 you can get everywhere. The interesting part here is it is compatible, backwards compatible to the 2600, not to the 5200, because the 5200 was also not compatible to the 2600. I think this was already under Jack Tramiel's leadership, whatever. And yeah, I think this could have been much more and much better, but it probably came out a bit too late, and I think the features are... I'm not sure. They are probably on par with the NES and the Master System, but those had much more games, a much bigger game library. I don't have a single game for this, not an original game. I have like 2 or 3 dozen 2600 games, a lot of homebrew games. Plus, for the 2600, I have the Harmony cartridge, which is a micro SD flash cartridge, basically. Very useful. You can play all the stuff that came out for the 2600, basically, and especially the more rare ones that you can't get a hold of, and a lot of demos and homebrew stuff that you can't even get a cartridge for. Aside from the cartridges, obviously, that you can buy for homebrew. And the same person, Fred Quimby, also made this thing here. This is the Concerto cartridge. And I looked around for 7800 games, and they are expensive. There are a few here in Germany that are okay-ish price-wise, but buying one game, instead I could, well, like, for the price of 2 of the cheaper games, I could get this one here imported from the US, which is, again, a SD card based, this time SD card, not micro SD, funny enough. And I think this came later. SD card based cartridge, flash cartridge. Also, I think compatible to the Harmony, because the Harmony uses the so-called melody technology. You see the musical names. Melody cartridges are used in homebrew games like Mappy, Galaga, and all the other Champ games, and a couple of other games. And there's a tiny little ARM microprocessor here, which enhances the sound and makes the bank switching faster, etc., and gives a little bit more ROM space. It doesn't render all the stuff or something, but it makes the games a bit more interesting and capable that you can do on the 2600. And I think this one also has that. So for the 7800, you can basically put away your 2600 plus your Harmony card and just use the Concerto card. Other than that, the 7800 uses the same cartridge port basically, but has 4 additional pins on either side of the central edge connector, so you get probably a much larger ROM space that you can address than on the regular cartridge for the 2600. You can see that here, that the cutout, there's a dust cover here, is much smaller. It's exactly the size of this thing here. So you can plug in 2600 cartridges without an issue into the 7800, and 7800 cartridges also, of course, but not the other way around. So this won't fit due to the larger edge connector into a 7800. So the issue with all of these consoles is this thing here. This is an RF output, radio frequency modulator, plus 9-volt AC input. And no TV nowadays has RF input anymore. Basically, I do have one little LCD TV with RF input, and I tested the 7800 already. And I can confirm it works. It also plays my 2600 cartridges. I didn't have the Concerto when I tested it. This thing is in pretty super great condition. There's even the sticker here on the bezel. I will peel it off once we've done it, but the mod, but not right now. All my CRTs only have composite or SVideo input, so I wanted to have a composite mod. I did a composite mod on the Junior, as kit by The Future Was 8-bit, which is out of stock at the moment. It's a very, very great, high quality composite mod for the 2600. I did my own mod for the 2600 Vader. You can find like 5 years back in my videos a video about that. It gave a little bit of a fuzzy picture. Not sure if it's about the components. Uwe, hi all, hi root. What's my pseudonym here on this old account? Ah, Kurt here. Okay, Kurt from Mastodon. You can also all follow me on Mastodon if you are not doing that already. Root42 at chaos.social. I am looking at the account every day, so you can chat there and stuff like that. But I was talking about the composite mods. And all of those also had to be in such a way that you have to remove the RF modulator, which for the 2600 I don't care about. There are still millions out there. I can grab a pristine one for very little money with RF output and everything. But when it comes to the 7800, especially a nice thing like this one, which doesn't have any broken off pieces or anything, I mean, I will probably have to drill 1 or 2 holes in here to get RCA jacks out. But I did want to have a little bit of RF here still, maybe just to keep it as is, sort of. So I looked around for a mod, and the usual mods are very intrusive, but there's one thing from a company called the Brewing Academy in California. Let me do it like this so I don't dox myself. This is the Brewing Academy. in Court Street, Woodland, California. They are selling all kinds of kits, and they are selling especially this one here. This is the Ultimate Atari Video for basically all the consoles and Atari 8-bit machines. It is designed in such a fashion that you can leave in the RF modulator. You just tap into the signals, and we will have to look at the audio, because the way they're doing it here is it will disable the audio for the RF out, but it's also possible to have that in parallel. So by just adding 2 more resistors. And we need a little 10 microfarad capacitor anyway. So I'll probably do that so that we have fully functional RF output and a fully functional composite and SVideo. I'll probably only pull out the composite because I have more monitors that do composite. Plus I think the picture quality, if it's a little bit fuzzy on the 7800, doesn't hurt. Makes it probably look a bit nicer. Yeah, but you see up here the PDF. I can scroll through that and you can follow along. This is something someone on the Atari Age forums put together for this mod, because this works basically with all the different consoles by Atari. So I think we should get going. We will need Phillips number 2 screwdriver. I think this should do, otherwise I have a little bit larger bit as well. Need nose, I think that's supposed to be needle nose pliers to assist with bending up the RF shield tabs. Yeah, we have something like that. Soldering iron, check. Solder, obviously. Length of small gauge wire to assist. No, because the wire isn't going to attach itself. Oh no, solder, yeah. Different colors make it easier for each connection. I only have blue and red, but I think I also have some green here, but that might not be long enough. Heat shrink tubing, we have that. SVideo jack panel mount, I don't have that. Matthias says, have this 7800 better performance than the Atari 8-bit series? Oh, that's a good question. Not sure. I would guess so, because the 8-bit series is from 1979 or something, and the 7800 is from like 1985, around that time, I think. So I would assume that it's slightly better. Don't know if it has more RAM, haven't looked it up. It has this fallback mode where it runs at 1 MHz, just like the 2600, with only the tier video chip. But let's open this up, because there's more than the tier and the Riot and the CPU in the 2600. There's also the Maria chip, which does the enhanced graphics with, I think, more sprites and stuff. And I'm not even sure if there's another sound chip. Probably not. I think the sound chip came on the cartridges. Like this Concerto cartridge also emulates a Pokey chip, which was used by a lot of cartridges. But yeah, we start by removing the top cover. There are 5 screws. I think. Oh, okay. Here's the seal isn't even broken. It's German warning seal. Achtung, eine Beschädigung dieses Siegels führt zum Erlöschen des Gewährleistungs- bzw. Garantieanspruchs. So we are voiding our warranty, but I think we all knew that coming into the stream, that the warranty will be void after this. Yeah, as I said, I don't have a mini DIN jack right now for SVideo output, and otherwise I would require at least 4 RCA jacks if I want Luma, Chroma, Composite and mono audio out, or even 5 if I want to do stereo, which this thing doesn't do, but I've done this on the Vader, for example. I just wire 2 RCA jacks in parallel, basically, which halves the volume obviously, but you get, like, you can just hook it up to any anything. Are you ready? Are we gonna break the seal? Ooh, this hurts so much, but I'm gonna do it. If I can find the screw actually under here. Damn it! I don't want to destroy it, otherwise I would have to drill it out. Ah, I think I found it. Yeah, found it. Oh, it's very tight. All right. Come on. Now I lost my bit. Here we go. So those are all of them. Let's see. Okay. Okay, good. Also, there are a bunch of people now in the stream. That's very nice to know. Let's open the case. And scroll up to the next page. There will be an RF shield in there. Yeah. Okay, there's only very minor amounts of dust. Looks pretty clean. And there are the tabs for the RF shield. Okay. I'm wondering if these pliers are okay for bending. No, they are too soft. Are the side cutters gonna? I think not, because I think I can't fit in there like so. Oh yeah, it might do. It might do. At least for some of these it will do. I do have some other pliers as well. So maybe I'll fetch them in a minute. Yeah, I think I have to. Question is where? Here. Here they are. Alright, these might do the trick. So my goal for tonight is that we get the mod running. I have the HDMI converter hooked up so we can have a look. This thing actually comes with a built-in game. It has asteroids built in, so we don't even need a cartridge for it to be playable. But my goal is to... Oh, okay. Oh, okay. They used some kind of foam pads. That's weird. Again, I want to get the board installed basically and see that the whole thing works via composite out, because that's what I really want. I'm probably not gonna do the drilling of the case and the installation. I think I'll take more time for that to think about where to best put the RCA jacks without having the case totally slaughtered. And I don't want to hurry that. But I hope to be able to show you how to do the mod if you ever want this. Note that this is from the US, so you will have to pay customs if you're not US based. In Germany that's 20%. And it's not cheap for what it is, because it's like maybe 24 SMD components. I think the bill of materials is probably only a couple of dollars. But I mean, they spent time to design this. I give them credit for that. And I think they were very fast with shipping. So it seems like it's a decent small company producing retro hardware stuff. And it's, I think, probably the least intrusive mod for any Atari 8-bit console or computer, so to speak. Grief. On this side it's a bit hard to get this off. There is, I think, a 7805 or something linear regulator, which seems to be good still, because the machine was working. But I'm always a bit wary of those. Darkstar says, Guten Abend. Good evening indeed. So, everybody joining now. We just opened up the 7800 and we will be installing this little video mod to get at least composite out, but it's also supporting SVideo. If I were to buy a DIN socket, that is, or drill more holes into the case, which I actually don't want to. So I'll probably stick with composite out for now. There is a slight issue here where the... there we got it. Where the voltage regulator is. Oh wow, there is a board that I didn't expect. This thing here. Okay. This looks different from what I see in the photo. And here's where it got interesting. Oh boy. Code asks, what's the price of the mod? The mod is, I think, $30 or something around that. Plus shipping, plus taxes. So you'll probably end up at 50 or 60 euros, which is way too expensive, I think. But I couldn't find anything else that had, because for the 7800 there is not much out there, to be honest. Very little in the way of modding, because it used to be very tricky, and everybody said this. And there's one other mod which makes you remove the RF modulator, but that's something I didn't want to do. So here we are with this expensive mod and a board that looks completely different from what I was expecting. None of the things are in the places they should be. I'm gonna zoom in a bit on the photo here. So the RF modulator looks very similar. There's also this little PCB that taps off probably the video signals, I guess. There is the tunable inductor here. But the resistors and everything here looks completely different. Hopefully it's only just like rotated, because we need to tap into those. We do have the 6502 down here, but there's a bunch of stuff that shouldn't be there. So that's the main CPU. And as I said, there's this weird board here sitting on top of several things. I can see those are all UMC branded, not MOS, as I would have expected. Different revisions of the boards, yeah, probably there are different revisions, because this is a PAL board, and it seems the PAL board is quite different from the NTSC boards, which is a bit sad, but maybe we'll figure it out. So my goal now is to understand what's happening here, to hopefully get this installed. I don't even see the main 5-volt bus running around here, because you can see here should be +5 and ground, two very, very nice large tracks. That I don't see at all here, and we need that to power our mod. There was a spider in here, it seems. I can see some cobwebs. Okay, so those are these things. There's a VLSI chip, which is probably the Maria GPU, as it says here, and that's probably the TIA. I'm gonna check if there is anything visible from below. Is there a socket? No, it doesn't seem to be a socket. So this could make, or is it? Okay, if I look under here, you can probably not see there. There's a gray thing here, pins probably. Yeah, this looks super different. Yeah, I think they soldered this in place. This, I have no idea what this board is for. But we can determine that this thing was probably built in 1990. This says 2890. Do we have any date codes? 1938, 1936, 9127. Okay, maybe even as late as 91. Yeah, 9119, 1924. I didn't know they were still making this in 1991. That's pretty late in the game, right? That was already Mega Drive territory, and yeah, that was long in the tooth. The question is, do we have schematics for this? Because I think I can almost stop here with the with these instructions here. Because we will require this to attach to several of the resistors. So we would need to figure out, we will need the schematics. Maybe we can do this tonight. And there will be a second stream when we install this properly. So we probably need to reverse engineer this mod insofar as we have to figure out what these resistors are in the NTSC version of the motherboard. Because we're tapping into, I'm gonna zoom in very closely, we're tapping into the sync signal and L1, L2 and L3 and L0. I think those are probably video signals. And there's co-in and T-call. I think those are color signals for probably the Maria and the TIA, because there's also a TIA and a Maria color adjustment pot, which you can probably tune to get the colors right. Max Videotron says, I'm in and out. I had the 7800 and 2600. 7800 could run 2600 games, but it didn't work all the time. Okay. And Dexor is here. Hi Dexor. So, for everybody joining, I was thinking about modding the 7800, but it seems we first have to do some reverse engineering. Because it turns out that this mod that I bought has instructions so far only for an NTSC board, I guess. Definitely different board revision compared to this, which is a PAL board, I would say, which has this weird little addition. This is a 74 HCT LS08N. HCT and LS, that's interesting. So that's the 7408. Some inverter buffer, I don't know. And there are two STC8506. If I didn't know better, I would say those are buffers, but I'm not quite sure. I'm wondering what was originally there, under there. Is there... Okay, the second IC isn't even populated. So there were two ICs that I can see here that are not on this one. The BIOS is probably this one here, the socket one. That's probably the firmware plus asteroids. This is probably the tier. I don't see it because it has a sticker on top. And this is the Riot. Okay, I think I have a spare Riot up there somewhere, but we don't need that. Dexo says, I always forget that the 7800 in the rest of the world has RF output. I have a French 7800 which comes with RGB card output using the same cable for the Atari ST. Yeah, that's actually one of... I think the 2600 is terrible in French because it only has a very small subset of the colors due to the TV standard. But I think the 7800 is actually better compared to the rest of the world. It has 8 colors, yeah, compared to, I think, over 100 colors in the original. Okay, and it's basically black and white mode colorized. Okay, I'm gonna, I'm not sure what happens to the window if I go to my other desktop now. I'm gonna call up I think this here. Let me sort around my windows so you can see me browsing for Atari 7100 schematics. So, 1 second, I will detach this here. In a second, I will have to I have to disable this for a second. And I will have to move my web browser here and share this with you so we can do this together. Where's there? Schematics. Okay, this looks a bit. Let's put this front and center for the time being, a little bit larger, so we can better read what's here. Something like this. Dexo said, the colors don't make any sense. You can get pink sky, blue grass, orange leaves on the trees with green trunks. There was a Seacam PCB for the 64. I've read somewhere. Did it have the same issues with the colors? 64? Like C64? I have no idea how they did that. Was the C64 very popular in France? I'm not very certain about that. So, Retro 6 seems to have schematics. Yeah, the Amstrad CPC was, of course, more popular. Okay, here we have the PAL and the NTC schematics. Okay, that is something we can actually work with. Okay, let's open this. Can we open this picture in Open Image in New Tab? And here as well, then we can compare somehow. Open Image in New Tab. This is very fuzzy. Maybe I can get a better version by clicking on it. Not really, right? Can I zoom in? Yeah, this looks a bit better, but it's very hard to... Okay, so that's how they do this. Okay, this is doable, but I should somehow get it to download, but it doesn't do like that. Click on the link above probably. Public files? Yeah, public files is probably... Yeah, that's true. Retro 6 are also pretty decent. I've ordered once or twice from them for Game Boy stuff. No, I don't want to switch to Chrome. Schematics and datasheets. Atari 7800. Ah, there we go. Öffnen mit. I don't know. Let's download this. We can open this in preview and put it in full screen here as well. Okay, sorry, I got kicked out of OBS. Where am I? Ah, here. Okay. Download. Okay, it downloaded both. That's good. I'm gonna combine them into... Can I combine them? Into... Which one do I have? PAL. No, I can't. Give me 1 second. I will try to open both in one window so we can switch between them. Something like this. Yeah, this works perfectly. I'm gonna close the browser for now, so you won't see that anymore. There we go. And I'm gonna pull in preview onto the screen. There we are. I have to switch my capture to this one here. Yeah, perfect. And I'm gonna move it so that we can see more of the actual schematic. Something like so. Okay. Hi Yannick and hola. Can I? Okay. This is how I can switch around this. So which one is this? This is the PAL version. And this is the NTSC version. They look very much different. They look very much different. Like extremely different. Oh boy. Okay. So what I would do now is to figure out which resistors they are tapping off the signals. I guess there must be something coming out of the Maria chip, probably, because that's generating probably most of the videos, video signals. I'm not sure how or if they switch between Tia and Maria, or if one is slave to the other. I'm not sure. So this is the 6502. This is the processor. This here is which chip? Probably the Riot. Maybe not. Does it say? No, this is the card connector. Okay, good. This is the card connector. This is U72333. I have no idea. There are two RAMs, 6116, so those are the SRAMs, which I thought would be... those are probably SRAMs, the 8506. I guess those are the SRAMs, because on the original NTSC there were two big Sony chips, and I think those were 6116s, because they had the big DIP, what is it, DIP 20 package, DIP 28, I don't know. So I guess STC 8506 are SRAM. why they're using this board instead of the Sony SRAMs. I don't know. Maybe there were shortages. Those were cheaper. Probably cheaper. Alright, so this is the chip stuff. This is, I see address lines, I see data lines. This is probably the BIOS chip, right? 24 pin or 28 pin, Note 5. Stefan Reifenberg is also here. Hello, Stefan. Everybody joining now. The plan was to mod the 7800. And it turns out that the PAL version that I have is completely different to what the manual says, which is a NTSC version. So we're now doing a little bit of reverse engineering by first understanding what the layout of the PAL board, of the NTSC board is, and then trying to find the same signals on the PAL board. Hopefully that will work. Not sure if we can get everything running today, but we'll see. 6532, that's the right chip. There's probably nothing in there for us. So where are Tia and Maria? This is Maria. Here we are. There's color, sync, luminance. Luminance 0, 1, 2, and 3. Those are the signals that have to go into this board. So we are probably good just hooking ourselves up to the signals here. The question is, where do they appear on the board? And we can probably, even knowing the pin out here, pins 42 to 48, just beep it out on the board. But it's probably easier to look it up on the schematic. Okay, I'm now getting a little bit calmer, thinking that we might actually have a chance of getting somewhere here. Where's the tier? Here's the tier. Okay. So it also has luminance 0, 1, and 2, but not 3. So it seems there's one additional luminance level. It's probably binary encoded, maybe not. So probably the Maria has twice the colors that the Tia has. I'm just talking out of my ass. I have no idea. I do know that the Tia has over 100 colors, so it might be something like 128, I don't know, but there's, I think, several blacks that are the same. And the Maria probably has one more bit for this, if that's something like a DAC. But I'm not sure. Is this some kind of DAC resistor ladder? Perhaps? Maybe? Could be. But there are resistors R19 through R23. Let me very quickly look at the preview of the... Where did I put it? Here. Oh, goodness. Okay, I will switch. I'm not sure what happens to the screen capture here, but I'm gonna look it up. It's not visible. It's not visible, sadly. They only show... Oh, come on. Why didn't they tell which resistors those are? They only show visually where the resistors are, but so basically we have to do a little bit of guesswork. So the luminance things go to U3. To U3. What's U3? Here the outputs of the Maria chip go to U3 and to J2, which is some kind of connector, I guess. Do I have a J2 here? Probably not. Oh, interesting. There's also something saying PAL and NTSC on here. And vid and aud. Video and audio. There's some test points for video and audio. That's good to know. The question is vid already the composite? But I think we don't have We do have composite in. Oh boy. Okay. One step at a time. Very slowly. U3. Let's first figure out what U3 is. The tier is U8. Its outputs also go to U3. 13, 4, and 9, perhaps? What was it here on the Maria side? 13, 4. 12, 5, and 10. Okay, what is U3? U3 must be some kind of magic chip. J2 peripheral port output. J2 peripheral port output. What's the peripheral port output? That must be some kind of pin header. That I don't know what it is. But that's not the cartridge port, right? Cartridge port was J1. Supposedly, at least on the NTC board, there's a J2 peripheral port that I don't see anywhere on the PAL version. Interesting. Let's have a look at the photo. I don't see a J2 here either. Maybe they had that in earlier revisions or something. Okay, let's compare the video signals on the PAL version. So we have U5 and U6. Here it's U2 and U3, and I think U5 and U6, I can't see it. U5 and U6 are probably the two sockets, you can see that, the two sockets here, which this board, this extra board is soldered into. Isn't the peripheral port on the Riot or something? But the Riot isn't called J2. J is an interface, I would say. The Riot has the joystick connectors J3 and J4. Right, left, down, up. Right, left, down, up for both joysticks. And those are wired directly into the general purpose I/O pins, I think, on the Riot. This is the Riot. Can you see that? Yeah. And there is there's here to the left. There's the stuff. And there is some additional things. J4, something, fire button probably. P2, P1 is probably pedals. Those go to the tier, because the tier handles the pedals. Then maybe it's the unused expansion port. Yeah, probably the expansion port, which I don't see. I think they left it out in these revisions at least. That's what I'm guessing. So what does the Maria on the PAL do? It has all the same signals, of course, color, whatever that is, sync, luminance 0 through 3. And there's another clock here, phi 3. Phi 2 is probably coming from the 6502, I guess. Maybe, because the 6502 has phi 0 and phi 1 usually. It doesn't matter. We don't care about the clock right now, because I think that's unimportant. This is also having something called J2, and it goes to a 74 LS32, which is some kind of gate, which probably gets input from both chips. The luminance from the Maria here, up here, goes down here, all the way around, and goes also into these gates. So basically I think those are OR gates probably. Where do we have a browser? 74 LS. What was it? 23? 32. Quadruple 2 input positive OR gates. So yeah, so that makes sense. If the if one of the chips puts out a bit on one of the luminance lines, it will get displayed basically. So you could probably even overlay both signals, I guess, because they are being ORed together. That being said, both chips probably do racing the beam, sort of. At least the TIA does. It scans the... I have to start here. It scans the screen and goes back and draws the playfield bit by bit, because there's no frame buffer in here. The 2600 doesn't have a frame buffer, and I think the 7800 probably neither. Not sure. But I would have thought that the ORing is basically a digital mixing, so to speak. And I would guess that you could pick up the video signal, at least the luminance levels here at these resistors. Resistors 11, 12, 13 and 10. Probably. This is M-lum 0. What is Maria luminance 0, right? Okay, so 3, 2 and 1 go in here. And Maria has an additional luminance value which goes here. And I think those probably will be connected to the pads here. There is documentation in the instructions. I'm gonna hold it here, trying to get it to focus. It's not really in focus, right? But there's like a whole lot of pads here, and some of these correspond to the luminance inputs, and I have to look up which. But my guess would be we need these resistors here, 15, 13, 12 and 11, which should be possible to find if... okay. The silk screen is obviously beneath the resistors. Oh boy. Okay, so we do have to beep out the... brilliant. Yeah. This will be kind of difficult. The question is, can we get... Did anyone ever do a board scan of the unpopulated PCB? That would help massively with the location of the components. Let's check that. Atari 7800 PCB silk screen or something like that. Is there anything like that? No. Not quite. Oh, good grief. Are we the first people to do this? I can hardly believe that. I guess nobody ever reverse engineered this. Okay. There's probably a lot of beeping to be done. I'm gonna resize the... Can I get... there was my screen. I want to resize this thing, make it a bit smaller, so you can see more stuff, and we can still see a little bit of the schematics. I can zoom in here. So what we are interested in is this portion here. There should be a 74LS32. The question is where. That's probably this one, because it says 74LS32. We get our multimeter or multimeter or whatever you want to call it. I'm going to put it here. We are going to put it into continuity mode. and we're gonna check out the signals. R15, yeah, okay. Let's forget about Maria luminance 0 for now. Let's first do the first test. The next luminance value should be luminance 1. I guess it's on pin 8 of the chip. 1, 2, 3, 4, 5, 6, 7, 8, I'm guessing. Or where do we start to count? Top left or top right? I still have the 74LS open, so I can look at the pinout at Texas Instruments. We start counting at the top left, obviously. I started counting at the top right, which was complete bogus. So, it should be this pin here, 2, 4, 6, and this one here. The question is, does it connect to any of these resistors? We might have to desolder the static RAM board. This looks like it's connected to something very different. Like ground? No. So it must be one of the resistors. Question is, which one? Ah, found it. Where are you? It beeps only once. Let's go to resistance mode instead. Okay, this is connected via 47 kilo ohms, which can't be the case. 8 kilo ohms. Okay, let's go to beeping. 3VI1J says, hello world. Oh, 7800 troubleshooting. Yeah, kind of. Reverse engineering is more to the point, because for everyone joining, I wanted to install this little nice mod, and I have the instructions, but the instructions are only valid for the NTSC version of the 7800. And we just figured out that the PAL version is completely different and has a completely different schematic. And we are now trying to track down the luminance values as a first approximation. And we're probably not going to make the mod work today. But, well, isn't this much more fun? I'm thinking there must be one of the... Okay, this one seems to be the one. This one here. Let's make a picture and let me scribble onto that. The question is, with which camera? Annoyingly, let me fetch another iPad and start it up, because it's not booted. It's turned off. I'm gonna, like grandma, I will do my photographs with an iPad. Nice. I did not know the PAL version was significantly different. Yes, it is. It seems to be, at least the layout is completely different. I mean, the signals are still there. The Maria and the TIA chips are the same, I think. But the routing is completely different. So we have to figure out where everything goes. Luckily, the iPad is already there. I'm gonna make a very old school picture here. Like so, I think. And then note which signal goes where. So pin 8 is probably luminance 1. goes to the third resistor from the bottom. So I do have a pencil that will help significantly in scribbling. I have to quickly pair it because I was using it with the other thing. So, do I get to use this? Damn it! How do I pair an Apple Pencil? Copy. Yeah, please. Okay, it's almost empty, but it will suffice for now. Okay, sorry for the delay. I have a third-party VCS Junior knockoff that I basically need to do this exact same thing with in order to add a composite mod. Yeah, that's exactly. I still say printer. Okay, so shall we print this out? The problem is I don't have a color printer, so this will probably look like garbage. But I will put all my notes online for future people who want to do a PAL composite mod, basically. I think that's just what we need to do. So okay, how do I scribble on this? Can I? Here. Okay, I think I found out how to use my iPad. I'm gonna use red. So this goes here, and this is luminance 1. So I'm gonna show you. I'm gonna draw it like this. This is luminance 1. That is what we have beeped out right now. Now we can check the next signal. The next signal, I think this is 1, 2, 3. This should be pin 3. That should be luminance 2. So that's here. So I'm gonna take a wild guess and say it's one of the other. Yeah, it's the 4th resistor. So then we have 3rd pin, which goes here, which is luminance 2. Then we have pin 6, should be luminance 3, I guess. Pin 6 is this one here. This is 7 pins on each side. Should probably be the one on top of that. No, it isn't. Am I making good contact? Oh, it's the bottom resistor. Okay. Obviously. We will double check if it's luminance 3, etc., etc. I've never worked on a 7800 before. I wasn't expecting that little daughter board there. That's what I thought. That little daughter board isn't on the NTSC either, but my guess is, as there should be 228, I think 2, 4, 6, 8, 10, 12, no 24, 24 packages, which should house 6116 SRAMs in the big packages. I think for cost reasons probably they switched to a different an STC 8506, where I think these are also 2 SRAM chips with a little bit of, I don't know, probably chip select logic, I guess, and 7408 basically, and a bunch of resistors to probably do pull up, pull down, I don't know what. So I think this is just a cost saving measure. I think, I don't know. Because otherwise I can't explain why. I think I do have a couple of 6116. I have 8118s, and I should also have 6116, I think. It would be an interesting experiment to desolder this board and put 6116 in there in the 2 sockets basically, and get rid of this ugly weird thing. But that's for future. Let's first get the video working. So pin 6 went to this thing down here. So this one goes all the way around here and to there. And we think that this is luminance 3, probably. The question now is, where does luminance 0 go, which is only available on the Maria chip, not on the TIA chip. For that, we are taking a good look at the Maria chip, and that's pin 42. Pin 42 is luminance 0, and it's supposed to go to R15. 42. Okay, how many pins does the Maria have? 2, 4, 6, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So this is a dip 48. Dip 48. We're looking at pin 42. 48, 47, 46, 45, 44, 43, 42. So this one here should go no to none of these. It goes to this one between the two inductors. So the green things here that you probably can't see very well, right next to the RF modulator, these should be inductors, I think. And that one in the middle takes the Maria luminance signal. I think, at least, that's what the beeping says. Sean Bruno says, oh nice, I'll be taking a pile of notes for the 2 I have that are needing repair. Okay, good luck with that. And let's take a note. 2, 48, 7, 6, 5, 4, 3, 2. So this pin goes over here and is probably luminance 0. Phew! What else do we need for the mod to work? Those are at least the luminance signals sorted. Let me check the instructions that I put on the other desktop. They also take sync, co-in and T-call. Plus they need +5 and ground, which we can pick up anywhere we have +5 and 3 and ground. That should be fine. But sync, and let's first search for sync. Sync output, let's look at the Maria, because I think it doesn't matter which one we take, is actually pin 48, it seems. However, there's a bar above that, so it is the inverted sync. Does it go through any kind of gate? No, it goes straight into the 74LS32. So it is basically on pin 11 of the LS32. I can live with that, and then we should be able to pick it up at R10. Alright. No, not yet. The pen. We first need to beep it out. Pin 11. Pin 11 of the 32. So this one has 7, 8, 9, 10, 11. Let's see where the sync pops up. I guess would have been that. It isn't. It's the second from the bottom. Everybody take notes. 8, 9, 10, 11. That's sync for you. So my notes are getting a bit weirder, but we will figure it out. Next is the color in signal, which I don't actually know what that is. Should be something on the Maria, I think. It's perhaps this one here, 43 M0 color. Maybe not. That goes where? Goes down here, goes down here, goes over here, down here, through R16, through an inductor, and then to the RF modulator. Goes also here, through R17, over here, up here, over here, up here, up here, up here, and comes out of the TIA as color. Yes, that's the color in. The question is, where do we pick this up? They pick it up at some resistor, which I don't know what it is. What's beeping? This is beeping. Okay, let's turn it off. So they pick it up at one of the resistors. Question is which one? There are two. There's R16 and R17. I'm not quite sure. How to figure that out? That's a really good question. If I knew more about this stuff, I could probably tell you. So I think the idea here is that, okay, I see that the Maria has TIA chip select and TIA clock. So those are, and it also, or maybe it generates TIA chip select, RAM chip select, 6532, that's the right chip select, and RIM chip select, whatever RIM is. Maybe the Maria produces all the chip select signals. Would make sense somehow. And it also generates the TIA clock. So it basically, I think the TIA is driven as a slave basically to the Maria, and is more or less. I do have a problem with my stream? No, I think it's fine, isn't it? Please drop a note if everything's still working fine, because my live studio doesn't show. It says very good connection, but doesn't say. Doesn't show a video feed, so I'm not quite sure. Otherwise, we're working fine here. Okay, great. And then it's just a hiccup in the studio. So my thank you all. My working hypothesis is that the Maria drives also the TIA via this TIA clock and the chip select, depending on if you're writing to the TIA registers. Probably, yeah, it listens to all it has all 16 address lines that it watches over from the CPU bus basically. So it probably knows which address the TIA is mapped to, I guess. So it will generate TIA chip select and TIA clock accordingly. I would guess that the TIA clock is always on or something. And it takes the color input from the TIA. Not sure about the luminance, if those are I/O. Probably not, because I think, as we've seen, the luminance is mixed in the OR gates, basically. So it seems that only the color is taken from the tier. From what I read in the instructions, but that doesn't make sense, right? Where does the color come from the Maria chip? But we do see a connection both here, down here, to the RF modulator directly via L1 and C8 and R16, but also to the tier via R17. And the question now is, where does the little board here tap into that color signal? Do we tap into that here at this junction basically, before the RF modulator, but behind both resistors? Because basically the tier signal is coming this way from the right basically, feeding into this junction, and the color signal from the Maria is coming from this way. And does it make sense? The question is, where do we pick up the signal? Because there's no further mixing basically. So my guess would be that we probably could tap into this at L1, maybe at this point. But maybe that's wrong, because all I can see in the instructions here is they tap into a resistor. And I can't say which one. It is the 2, 4, 6, 7th from the left in this big resistor line of resistors. Let's see. Let's go to the NTSC schematics for a minute. And let's see where here's the Maria. Here is the color signal 43. And that goes to MCall on R16. Okay. That should be where? Okay, here's the here's the OR mixing of all this stuff. Aha, okay, look at this. Okay, here we have a similar arrangement. We have R16 and R17, which is the M call, which is Maria color, and T call, TIA color. They are basically probably alternatively enabled. There's no mixing like an OR gate, because that probably is an analog signal, I guess. I'm pretty much guessing. Quick note, I will give ourselves here 10 more minutes for the completion of the reverse engineering, and I think in like 2 weeks time or something there might be another stream where we'll continue this, and I will probably have to do some more reading before I can finish this. But yeah, interesting, I hope, so far. The question is still, where do they pick this up? I mean, it could be that they are picking it up here at R2. That what I'm seeing is R2, which is a 470 ohms pull-down resistor, it seems. For whatever reason. I don't know why there's a pull-down here. But I'm not an electrical engineer, so I have absolutely no clue. The resistor, I can't even see. I said it's the 7th one from the left, right? 2, 4, 6, 7. Let's look up the value. I can probably look up the value. No, that picture is too bad. Can anyone find a picture of an Atari 7800 motherboard where we can see the values of the resistors, like the color codes? Is there a very high... there's a picture of the PAL version with the 6116s in place. Ha! There we have it, yes. Okay, that's nice. This is also the PAL version. There is a picture on Atari H, but it is very blurry. So, can anyone please find the resistor values in this huge array of resistors? Oh no, this is way too small, 160 pixels. That's nothing. Okay, here I can almost see them. 2, 4, 6, 7. Oh. So yellow, purple, red would be 470 ohms. Could that be yellow, purple, red? 2, 4, 6, 7. Very hard to see. I couldn't tell. My hope would be that it is, but there's a lot of pictures of PAL motherboards, interesting enough. There's one unpopulated. Okay, that's good. That's good. I found an unpopulated, mostly unpopulated board. 2, 4, 6, 7. 2, 4, 6, 7. That's R16. They're picking it up at R16. Interesting. Why are they picking it up at R16 and not R17? Doesn't it also have to be? Ah, that's T-call. Okay, they're picking up both. Okay, that settles it. So they're picking up both signals separately. They're picking it up once here and once here. And now let's have a look where that is on our board. Zooming in. No? Can I please zoom in? Yes, almost. So, we can do this as well. So we also have R16 and R17. That's something that we can do. It has the same names, the place is different. So color is pin 43, and that would be key call. So they call it call in. No, that would be M call actually. I would call it Maria color, but they call it call in. Not sure about the name. I think M call would be better. T call and M call would have made it clear that they are picking up both signals. So let's zoom in a bit more. Color is pin 43, and we had 48 pins, right? So 48, 7, 6, 5, 4, 3. None of these. Okay, that would be this one here. This one here should do the trick. That at least has the signal we need. 48, 7, 6, 5, 4, 3. And I drew over that part that I need to M call, I'm gonna call it. Okay, next up would be the TM color. Sync seems to be same for both chips, I think. Probably. Ah, yeah, that was also combined in the OR gate. The Maria color, the TIA color is pin 9, which I probably can't get to. 1, 2, 3, 4, 5. Yeah, it's below this thing. I think we might have to do some desoldering. Not a big fan, but that would give me the opportunity to use 6116 RAMs. Oh boy. Let's see if I have some. Then we could do that mod as well. Let me check. I'm pretty sure I had some. Maybe in here. Maybe not. I think I bought some the other day. Question is where? Do I have a box of SRAMs? These are Sims and other RAMs. DRAM and SRAM. These are the wrong kind of? Oh, let's see. I think these might be... There's a 6264. No, sorry. That's the wrong kind of SRAM. Maybe we can put in the original ones again. Yeah. Okay, I think we will have to desolder this thing. So I'm gonna power up the noisy desoldering gun. And I'm gonna turn this off for a minute. Yeah. We will quickly desolder this. And then we will have to close the stream. But we will first beep out the last signal, the tier color. Maybe we don't even have to do that. Maybe we can trace this on the backside. Isn't that a great idea? I'm pretty happy that I got this idea. Let's turn off the noisy things first. The tier has its notch over here. So 2, 4, 6, 8, 9. This should be the color signal. Alright, this should be the color signal. Let's make a little mark that we can remove with some isopropyl alcohol. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here is a little arrow. I probably can't see it, but I drew a little arrow here on the solder mask. Thank you, Through-Hole Manufacturing. Yes, indeed. Let's go back to beat mode. This is the thing, and it will go somewhere. There is, I think there's a via somewhere. But I think we should be able to pick it up somewhere near the RF modulator, just where the other components are. This is the RF modulator up here, and I think we picked up most of the stuff on this side here. So let's see. Nothing here. Nothing here. What else do we have? I need a brush or something. I think there are brushes for testing large parts of the board. Oh, it could be one of these. Nothing yet. Is this correct? The tier says color is 9, yes. That should do the trick. It also goes here to R22. Well, yeah. If we find R22, that would also be sufficient. Am I on the... Oh, come on. No, of course not. It was the wrong pin. Where is my thingamajig? So, the right pin is this one here. Right across. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one. I'm sorry. Test again. None of these. None of these, it seems. Yeah, it is beeping if I short it out. So where does this end up? Is this in the directly connected? It makes this turn here, goes down here, it's a second, then goes around here, 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 and then goes straight into R17. Yeah, that should be fine. So the question now is, where is R17? It should be right next to R16, right? That would be my guess. So it should be one of these couple of resistors. Let's test these here. What was this pin? This one is very elusive. Where might it be? If any one of you Googles, can Google 7800 Palm motherboard and maybe find where the R16 is, that would be awesome. So this one here says R25. We know that the one on the left is R6. No, the bottom one on the right is R16. This one here is R16 because that was the M call. Probably R16. Could also be R2. No, can't be. Because then there would be 4.3K in the way. So it must be R16 here. So I would have assumed that R17 must be somewhere around here as well. But I can't make it out. What else is around R16? Can't say. That's very tricky. 1, 2, 3, 4, 5, 6, 7, 8, 9. We are on the correct pin, I would say, finally. Because this is the TIA chip. There is pin 1, right there. And this is the 9th pin. So there must be something around here that is R17. Question is, which of these? Oh, this is a transistor. This is not it. This is, I think, one of the chips. Must be connected somewhere. Can't see it, can't see it, can't see it. Then I will Google Atari 7800 PAL motherboard. Let's see, do we have any images? That's populated. That's all populated. Do we have something unpopulated here? That would be super cool. No, but there is someone showing, highlighting some resistors. No, there's nothing. Maybe we can look at this together. Let me very quickly put away this close window. Now you probably don't see any updates, but we're gonna switch to a different window, to this one here. So let's look together for a proper motherboard photograph where we might be able to see that. Here you can actually see these are the 6116 SRAMs that are replaced with this weird contraption here. So that's that. Oh, there is a mod. But this is the NTC board, or at least this is, yeah, I would say. This looks quite different. This is an NTC board. This is something completely different. This is probably an Atari 8-bit home computer. Now let's try Google instead of DuckDuckGo. Okay, piggyback board, yeah, we have that. The second type to manage pairs of 2168 memory chips in lieu of the typical 6116, yeah. I think the piggyback board looks horrible, but yeah, what are you gonna do? There's a, oh god, this looks weird. There's something completely different. No, let's not go there. There is a nice picture of basically our board here, but doesn't help. I want something unpopulated, if possible. Daxa, that was the French version with the SCART outer board. Okay, I see. Interesting. Look at this. This might be useful. There is something. 2800 chroma. That's probably, and that's. Is that the TIA chroma? Maybe the color. That could be external audio. So that would be the third from the top in this row of resistors, basically, or the fifth from the bottom. 2, 3, 4, 5. That would be this one here, and they're tapping it off on that side. That should be this pin. Let's deep this out. This gnarly little thing. Let's check this. I think I checked this, but maybe. This reads 1.4 kilo ohms. That's way too high. 9, 9, 46, 16, 18. I mean, that's the lowest of the bunch. No, now it reads something. Ah, okay. 1.4. 837 on that side. 1, 2, 3, 4, 5, 6, 7, 8, 9. It has to be this one. Yeah, those are all in the hundreds of kilo ohms or mega ohms. Yeah. I'm not quite sure. Is there anything else in the path? I sadly closed the preview. With both the let's pick the part schematic again. I don't see anything in the signal path there for the tier color signal. I mean, there are 1K resistors in this deck ladder arrangement from R19 to R23, which could mean that we are measuring that, but I'm wondering why we would be measuring that. That would mean that I found R22 instead of R16 or 17. Weird. Let's keep this information in the back of our heads, and I'm giving myself 2 more minutes to try and find something more clear and concise. Otherwise I will have to go back to the drawing board offline, and we'll see in the next live stream how to proceed on this. I'm also very much open to suggestions. I might post something on the Atari Age forums, because I guess someone must have done this. And I'm also gonna ask if this weird piggy board is a sensible thing, or if I should put in some nice fresh 6116s. But I said I want to keep it mostly original, so maybe I'll leave it in, this weird thing. I might want to put it in a proper socket. Probably not. But this is weird. This looks, it's at an angle, I hate it. But so it shall be. Thing is, I don't see, oh god, look at this. Look at this mod. Modding a 7800 always looks like garbage. It's so chaotic. It's crazy. Can we see something here? There's a lot of stuff removed. R62, that is, I think, they left some stuff here. That's also a composite mod, and they removed a lot of things, and the RF modulator, which we want to keep in place. They don't tap off the other things. No, I don't think this is what we want. There is the image that I found before. there is another NTSC board. It's so annoying that there's no unpopulated PAL boards so far that I've seen, so that we can see the silk screen. I think maybe people deem them too valuable, because it would be nice to have a proper scan of the boards, because the silk screen is very annoyingly not visible. Yeah, I think I will have to give up here for today, because I can't seem to find the connection between pin 9 of the tier. Let's look if it's really pin 9, because that would be something. Atari tier pinout. That should be possible. Aha, here we go. On the PAL. Oh, that's pin 9, yes. Pin 9 on the PAL. That's supposedly like so. So that's the one at the bottom here. 2, 4, 6, 8, 9. Yeah, that's indeed the one that I found. And the question is why, and it should be this resistor here, but for some reason I'm getting 1.4 kilo ohms. And even pushing a bit harder, if there's any corrosion or something, no. This is definitely 1.4 kilo ohms for some reason. Why is that the case? Can anybody tell me? Hello Datort. We are basically at the end of the stream for today. Let me do a quick recap. Very nice chat here, very supportive. We opened up the Atari 7800 and we're in for a big surprise, because the instructions to the little composite and SVideo mod by the Brewing Academy, which is an excellent piece of kit, even if a bit overpriced, but the only non-destructive mod I could find that also leaves the RF modulator in place. Well, the instructions only talk about the NTC version, and it seems that the PAL board looks completely different. The components are mostly the same, even labeled in the schematics the same, but the layout is completely different. So we had some trouble figuring out where to tap the signals off. We beeped it out, we looked at the schematics, we found most of the signals except for the tier color signal. I do think that it comes in here at the top. I might do a little desoldering to lift one leg of the resistor to see if it's actually R17. But then I still wonder why there's a 1.4 kilo ohms reading instead of like 0 ohms, because it's connected, should be connected directly to the tier. I might desolder this thing just to get a better look at the PCB and do better tracing from the top. That might be easier and more reliable. This weird board is the SRAM, the main memory basically of the console. For probably cost reasons they put this weird contraption on there, but I think you can probably take this off and put in sockets and 6116 SRAMs, which I probably won't do, to keep this more original. But the state of this mod right now is I know almost all except one signal. Once I figure that out, we can start attaching wires to the board, and here we also have to find a nice ground pin and a nice 5 volt pin, but that should be easy enough. And then we could be testing the composite out, and it also supports SVideo, but I would have to wire up something to a mini DIN thing, and I don't have that right now. Yeah, that's where we are currently at. So that will probably be it for today, because it's already 20 minutes longer than I expected. But yeah, Dartward asked, didn't know you do live streams too. Is this a common thing on your channel? I wouldn't say common. It's definitely not regular. But you can look in my video backlog. There are a bunch of Lötstreams where I, and sometimes also Soul Sister, solder stuff. R16 and R17 are connected on one side. That is true. That's actually true. We could beep out that. I will do that later. Thank you, Video Disaster. That's actually a very clever point. Let's do it very quickly. R17, or the other one was this one down here. So we can probably test on this side. And it should beep when I touch. Oh, this is open line. This is 7.4 kilo ohms. Okay. So there must be some other resistor that I don't know. But I would expect it to be very close to the RF modulator. Okay, didn't find it right away, so has to wait. Have you thought of taking a picture of a French 7800, since they basically implement some form of this mod from the factory? I can take any picture you want, by the way. Sure, Dexor. You hopefully know my email address. It should be on my channel. Otherwise, you can send it to route42@route42.de. That should arrive, I think. Yeah, but that's the state of things. The machine currently works, but only with the RF out, and I want to keep the RF out, but I want to have composite and perhaps SVideo possibility in the future, because I have more monitors that support that. I only have one TV that supports CRF. But I think, yeah, we got a bit into this mod, but much less than I hoped to be totally honest. Yeah, I thank you all very much for giving pointers and hints. And I think having to reverse engineer a bit is actually a bit more fun than just putting in the board and hey, it works. It's actually much nicer to understand how this thing works. For example, that this LS32 here is basically the video mixer for the Luma signal of both the TIA and the Maria chips. And since it's a digital video signal, it basically ORs everything together. And I still wonder if you can drive both chips at the same time for some weird overlay effects or something. Because at least on the Luma level that should work. On the Chroma level, would be interesting to see what happens if both outputs are enabled at the same time. Not sure. I don't even know if that's possible, or if the Maria is active, the TIA chip select is always inactive or whatever, or it blanks the output of the TIA. I don't know. Interesting thing nevertheless. So interesting way of Atari doing stuff by having two GPUs, if you can call that, or video generators on board, and one is only for the 2600 emulation basically. So that's pretty neat. But I've been already way over time, so I think I might do another stream in 2 or 3 weeks. I'll take a little bit time off of this. I will try to research which is the correct resistor, and Dexor, if you can take some pictures, that would be nice. Yeah, but I also might start lifting legs off 1 or 2 resistors where I think they should be R17. I don't want to desolder everything because that will be very dangerous a little bit to this over 30-year-old PCB. So I want to avoid that as much as possible. Yeah, but that's it for today. Sorry for the little letdown. I was already having the HDMI converter connected to show the composite mod when it works, but it wasn't meant to be today, so we'll do it another time. And thank you very much. Make sure to check out all the rest of the videos. We're probably also going to do another Lötstream with some more chatting and simple things. We still have one more bag of Blinky parts goodness here, and I think there's a lot of stuff in there. So I think Soul Sister will be pleased to be able to solder that. And yeah, see you next time, and thank you. Bye.